So two things to take note of. Please do take note that now for iodine, it will be pale yellow with silver nitrate. For thiosulfate, it might give off the off-white pale yellow precipitate with hydrogen ion. For this reaction, please leave the test tube after you add the acid for a few minutes. Do take note, this will be provided under qualitative analysis notes. This keyword is important because you need to see whether the question got it or don't have it. Now, I want you guys to do something for me. Before we open the mark scheme, right? I want you guys to do a bit of analysis. I'll give you guys a few minutes to read the question and do some analysis. Now, I want you, like I said, when we do this type of question at time, must always do pre-analysis one. So pre-analysis of, for example, this one, got say the keyword qualitative analysis notes. That means for FA10, right, can never run out of the ions behind. So the answer must be somewhere behind there, except for a few, a little bit different. For FA9, right, why they never put part of the qualitative analysis notes, right? It is because of oxide, because there is the existence of oxide. So therefore, you need to refer a bit of your knowledge to AS. They can do this. They can test out, not necessarily all the question must refer to the qualitative analysis notes. Sometimes they'll use reactions from your AS paper 1, paper 2. I'll give you guys a few minutes, maybe 2 or 3 minutes. I want you guys to read through this QA one and then just do a brief note of description only. So for example, this one is testing for sulfate, sulfide. This one, testing for halide. So I want you guys to try to guess how you want to handle this and then have a preliminary plan before you attempt the question. Can I give you guys about 2 minutes just to read through this question before we look through the mark scheme, and then we see whether how your plan wants to fit through this. So I'll show you both ways, how I will attempt to tackle this question, how the mark scheme, what is the final answer will be. Okay, now let's go on with this. Okay, the first thing I'll advise you is they already give you the advice to tackle for the anion already. Okay, why they give you the advice to tackle for the anion is because most of the time with oxide and carbonate, right, they are insoluble. They are insoluble. So most of the time, what happens with this type of question is it will most likely be a solid. They will be insoluble. Okay, so now for this type of question, it is very straightforward. Good. Okay. Okay. Now this is much easier. Like let's see. Now, so to enter, so they give a long list lah. So usually again, this is 2 points for 1 mark type of question lah. Of course, they say heat it up lah. They say heat it up, right? I don't recommend heating it up for one very good reason, because it'll take too long. I don't recommend heat up. For example, you want to test for carbonate, right? And oxide, right? Your carbonate will react with acid, right, to give you the CO2. Okay, so you heat up also will release the CO2. It's just that heat it up right, will take too much time. So recommended for you is actually you just add it with acid. So the difference between this and this, right, is that if you think about it, right, for the first one, right, if oxide with acid, right, you will have to see hardly no change. But if it's carbonate with acid, right, the keyword is that you must put there effervescence. And then you test for the gas. Okay, here's the key part that I want you guys to all take note. If let's just say you know time to run the effervescence reaction, there are a couple of effervescences could happen in carbonate. It could be with hydrogen gas, it could be oxygen, it could be carbon dioxide. This one reacts with acid, so you know very high chance is definitely carbon dioxide. If you know time to run it, let's say you want to repeat again, make sure that when you do this at time, you have written everything else ready. In fact, my honest answer is that I'll prefer if you write out in pencil, effervescence form, gas turn lime water cloudy. I prefer you write it in pencil. Once you confirm that, then you put it in pen. Because if you know time to run the experiment, right, preferably that's the answer you put in already. But it can confirm it by running the reaction through, because it's a very straightforward experiment. And running through lime water, do you need to take very long? You don't need to take very long. You just need to take a few moments on it. It will just take turn a little bit cloudy, got a little bit white, done already. So for that one, is gas will turn lime water cloudy. And then you must mention that the solid dissolves, forming colorless solution. Okay. Now, why do you run that off? Because it's 4 marks. There's a lot of 2 points for 1 mark question. You're not going to get minus marks, right, if you write more. They're not going to penalize it if you write more, because that's what you observe. Write more is okay. Then after you got this, right, the whole entire solution only the cation. That's when you test for the ammonia test and NaOH test. That's when you test for the sodium hydroxide test and ammonia test. So to a solution made using the acid, because you dissolve it already, so that one will get you at least 1 mark. Then you add sodium hydroxide, ammonia, add both. Test both of them, what precipitate with sodium alkaline. That's how you get the final answer to be zinc carbonate. Follow me this so far? Now, let's just say you neglected, you don't have the same observation, you don't manage to get this zinc carbonate, maybe because you feel like your observation wrong, the observation wrong. But notice until here, until you use solution made by acid, here only 1, 2, here only 1 mark. Here also half of 1 mark. So even if let's say you get the wrong observation, just by doing the anion until here, you already get 2 marks already. And you have the white precipitate, you already have gotten 3 marks already, even if you were to get the formula wrong. Make sense or not? So most of these marks here is just through writing a lot. Okay, now if it's oxide, right, what do you expect? If it's oxide, right, you can say no effervescence form. So what you do is that, but you still see the solid dissolves. you still see the solid dissolves. So one thing you can do is that for the oxide, right, you can test it with litmus paper. You can test the oxide add some water, see if it dissolves a bit, test it with litmus paper. That's also another way you can put in more points. Don't know whether they'll accept or don't accept, but don't care. You still need to get a test, right? If it's oxide, that's how you test it for. Justin, because oxide, right? If let's say, no, you don't add in acid, you can add in a bit of water, take a little bit, add in water. Because sometimes the oxide, right, may be partially insoluble. So you see whether the oxide will dissolve in water, right? React with water to form hydroxides. That's when you can test for litmus paper. All right, next one. Let's go test. Let's look at this one. Okay, this one, right, is a bit interesting. Okay, this one consists of ammonium. Consists of SO4 2- and consists of Fe3+. This one, I think, relatively straightforward lah. Why precipitate form? Because there is sulfate. Therefore, when you add dilute hydrochloric acid, it's insoluble. Because remember, a sulfite and sulfate will both react with it, but sulfite will dissolve a bit, will partially dissolve a bit. Sulfate will not dissolve. Now, for the test 3, right, is no silver nitrate. However, when you add this one, right, you may say no change. However, you form the brown precipitate form, because in this particular one, right, you actually have the Fe3+ reacts with the ammonia. Because the ammonium solution is basic, so there's some hydroxide inside there. Therefore, you form iron hydroxide. So if adding silver nitrate won't have any reaction, that was true. But when you add the ammonia, remember the ammonia not only react with the precipitate from the silver nitrate, it can also react with the iron 3+. So you form iron hydroxide, brown precipitate form. Okay, brown precipitate form. So for this simple solution, this is the same one right here. Here also brown precipitate form. Same thing, because it's both ammonia and sodium hydroxide got the hydroxide, both will form iron 3 hydroxide. That's the brown precipitate. Okay, now warm and heat gently. So you must say insoluble excess NaOH. Warm and heat gently. Because it's of the ammonium, the gas turn red litmus paper, then red litmus paper, blue due to NH4+. Because the hydroxide, although will form the brown precipitate, right, also will react with the ammonium. So sometimes I understand why it become a little bit tricky for you guys to identify what's happening, because you have like a bit weird. Actually, you notice not the first one, right, the brown precipitate, this one, right, the brown precipitate form is thanks to iron 3+. The second one, right, gas turn red litmus paper blue, right, is actually thanks to ammonium. Now you may say, sir, how do we know we need to test for ammonia? Because of two cations. Because of two cations. I cannot confirm it because I need to analyze the past 5 years, but most of the time, when they suddenly put two cations inside there, many times the other cation is ammonium. It is because if you put another cation, right, you won't just form one brown precipitate. Imagine you have one chromium and iron inside there. Oh, then the thing will become very messy. It will become green and brown precipitate. So most of the time, in order to be a bit easier to test out, to see the results, there are two cations. One of them is sometimes ammonium. Actually, most of the time it's ammonium. So this is how you know it's ammonium. Because you see, you form a brown precipitate here, right? Then what's the other cation? Because they already say it's part of the qualitative analysis notes. The rest all form precipitate. So if one of them is the brown, clear brown precipitate, what is the other one? Highly chance it's ammonium. That's how this is tested for. So you can say this is a bit tricky because the only one that gave you an idea is actually right here. This part that only gives you the idea of ammonium. Last but not least, sometimes they like to put in a little bit tricky, so they put in the aluminum foil inside there. So what happens is that the aluminum foil will release hydrogen gas. Effervescence will form, hydrogen gas released, the gas will turn, will release the pop sound. Now, if you know it's hydrogen gas, no time to do the pop sound, then you just put inside there. Effervescence occurred, gas release pops with lighter splinter. And what happens is that the aluminum foil will react with water. The aluminum foil will react with water under high heat. So until here, so far makes sense. This is all standard. Only this part a bit tricky because got two cations involved here. Now, the biggest problem is all, now this is where I want you guys to be careful because I noticed this couple a couple of times already. At aqueous potassium iodide. So what happens is that you're actually going to get a solution turns brown. Okay. Then add aqueous starch. Solution turns blue-black. Okay. This is what happens. This is actually a redox reaction because your iron 3 can be reduced to iron 2. So what happens is that your Fe3 plus becomes Fe2 plus, and your I minus goes all the way to become I2. So it is this I2 that is responsible for that brown color, to which then the I2 will react with starch to turn into a blue-black starch iodine complex. This is the starch iodine complex. Frankly, this one does not tell you much about the ions inside. It only tells you that one of the ions is actually an oxidizing agent. That's all it tells you. So this one is what I like to call it noise. As in, if you are trying to figure out the ions from here, right, gone case. This one is noise is because they are testing for observation. So this is what I want to do today's class a bit, because I realized that Cambridge like to trick people a little bit already when they like to put in some noise observation. So you may think, how does this relate to the ions? Or you try to figure out, you wasted half an hour. So be careful a bit. Be careful of noise. Cambridge like to toss in certain experiments, less about finding out the ions, more for just to see your observation skills only. That's why. Okay, everybody follow me this so far. That's the idea behind it.